welcome tonight. Let me introduce Charlotte Richmond, who is head of talent, head of operations, head of everything. That's what I always say about Charlotte. She seems to do so much at her organization, which is Amy. And Amy's based in Milton Keynes, a wonderful scale-up company who are really starting to become a fabric of our society. And Charlotte, I'm going to ask you a little about how you hire in your business, looking for people who are non-practitioners, but what you hope and expect them to know about the discipline and domain. But before we do that, what was the spark or the magic moment for you?
Yes, I'd already been at Amy for a little while actually, and I probably shouldn't admit that I wasn't really interested in AI specifically when I joined the company. I think for me, there was talk about a project that artificial intelligence had been used for to do good, and it had made a real impact for humans for people's lives. And I have a background of working in psychology. I was a mental health nurse, and I started to see the connection as to how AI and data could really have an impact on things like the NHS and how we diagnose people and how we treat people. So for me, that's kind of that moment kind of stemmed my interest. I think as a non-technical person, it had always been something that I never thought I could understand. It just wasn't for me. But being able to put them two things together was my moment, I guess, and when my interest came from.
It's amazing. So tell us a little bit more about Amy so we can understand more about the company and then your role in business.
Okay. So we kind of have two areas of the business. We have our professional services team. So we work directly with clients at quite a strategic level, and we utilize, data, AI, machine learning, our creative team. So really heavily focused in on the user experience and the user journey. And then we also have our own product called Insight Maker. And in my very, very simple layman's terms, it's a data trawler. So we've got our own internal product team as well that look after that. So they do all the development. Sorry, what was the next part of the question?
And your role in the business.
My role, oh yeah, me. So I'm the talent manager. My job is to find people, get them into the business, and look at things like retention, keep people happy and developing. That's a really big part of my role, is making sure everyone's kind of growing in their position and happy, so that I'm not constantly backfilling people.
Wonderful. Let's talk about how you hire them for a moment. Obviously, you have your developers and your practitioners, but then there's a lot of other people in the business who work in customer service and in marketing, sales, and so on. And how do you discover who's got the right kind of passion for this type of technology when you're interviewing or reviewing CVs? What are you looking for?
I guess I'm just looking for passion. It doesn't necessarily have to be purely in technology. It can be quite obscure. I'm of the thought, and I like a CV that's got a bit of a personal statement, but more so the little about me. So someone that talks about things they do outside of work. I always find that kind of more interesting in some ways than what someone does during work. So I guess, when I'm looking at profiles and applications, and that's from very much entry level, graduate level, up to senior principal level, director level, and everything in between, I want to see a bit of personality. And you mentioned earlier, Amy is a scale up, but we're still, I guess, in that startup mentality. So we're a high energy company, and we want to bring people in that are going to kind of keep up with that high energy, but also improve on what we're doing, have new ideas, and have different passions perhaps than what we've already got.
Fantastic. But specifically, help me out on the AI side of things here. What would you want to see on that CV? Do you expect somebody to have gone on to Coursera or done some learning platforms and started to do some courses on AI? Is that important? How do you know that they've got a real interest?
Yeah, I think that does play a part. And obviously it does depend on the level of experience they're coming in with. So it might be someone that's, coming straight out of education, or someone that's perhaps having a career change. So I would be looking for, what have you done off your own back in some ways? Have you taken the time to do some self-funded courses in your own time? Have you, joined groups like this? This to me is a great thing if people can talk about, different groups that they're attending and workshops and webinars that they're listening to and that sort of thing. I think having a course behind you is fantastic, but actually you can also get a lot more from building a network through these sorts of events. So that's the sort of thing I look for. And obviously when I'm speaking to people, and I try and sort of reference these sorts of things just to see if that's what they're getting involved in, and are they broadening their horizons in quite a varied way.
Some people, of course, a job is a job, but those aren't the type of people that typically I know your organization hires, and you have the luxury of choosing, which is wonderful to have.
Yeah.
And so what kind of questions might you ask in the interview to understand their ideas and thoughts around the domain about AI?
So I try to tailor it to their experience. So I'll read through their CV and try and pick out something that they've talked about. So I don't like to use like a blanket question that I'll use on everyone, because it's going to be great for some but not so great for others, and I want to give everyone a chance to shine. So I'll try and pick out something that they've mentioned in their CV, a course that they've done, or something, event they've attended, or something like that. And yeah, I guess I'll just ask them to expand on it. A big part of what we do is consultancy as well. All of our roles are client facing. There's no one that's sort of just hidden away in the office or at home at the moment. So I try to kind of give quite open-ended questions in some ways to see how they respond and how they present themselves. And obviously at the moment it's very much video calls rather than in the office. Yeah, I try to pick something that I know is going to be of interest to them because they've put it on their CV. And they should really be able to talk about that.
Do you find that there's people have different angles and areas that they particularly like to explore? So if somebody particularly is interested in the ethical side of AI or how regulation works, is it okay for them to just really spend their time learning about that and bring that sort of enthusiasm in, or do you want somebody more rounded?
Again, I think it depends on the individual. And I know some people really do hone in on one particular area. As a consultant, I guess the preference would be to have someone who has a wider knowledge base, because you are potentially going to be going between different clients, different projects, and need to have that wider understanding. But what we do tend to find with our consulting team is they'll have a broad knowledge, but they will have a specialist area. So, and me personally, I learn best when I'm learning something that I'm interested in and that I'm passionate about. So if someone's going to be able to put their energy and time into an area that they're really keen on, then that to me is, they're going to get better results.
Yes, and I know that you give your consultants and others opportunities to speak and be on panels and forums, including our own sometimes, which allows them to take some of those particular areas of interest out into the world and explore them in more detail. I'm obviously monopolizing the questions here for Shah now that we've got her in the room and her attention. Particularly those that are looking for their first or next job in AI. What questions does everybody else have for Shah? You can type
I have a question. I have a question.
Hey, Kathy. Sure, yeah.
Hi, how are you? Hello.
Really well. Great to see you.
Thank you. I'm looking to, I have two interests, one in testing and one.
All of us to remember that period.
One in testing and one in development, but I actually would like to go into development because my background has been in testing. And I was just wondering, how can a person transfer their testing skills into development? I've been taking courses online, going to meetups and taking free courses that they offer online, as well as practicing myself. How can I get myself in a position where I can transfer my testing abilities over to development? I do have an IT degree, and I have developed before, but not as much as I would like to professionally. So how could I get myself in a position to do that?
I think you've kind of hit the nail on the head in some ways. You talked about transferable skills, and I think, when you're doing applications and applying to companies, it's really selling those transferable skills that you've got from testing to development. I know in our development team we have QA testers, and we've got people that do testing. So maybe it's looking specifically for an organization that will utilize your current skill set and then give you the opportunity to grow in the area that you want to. I know that's something that we've done in the past, is bring people in one role, knowing full well that they want to transition over time into another. that might be a way that you could maximize your skills right now and then still get to where you want to be elsewhere.
Okay, thank you.
Thanks, Kathy. Any other questions for Shah while we have her?
Charlotte, this is Matt again. I have a question for you. I'm kind of working on projects and Kaggle and building up a portfolio. And what do you look for in portfolios? I've talked to some people that said, you should have a really perfect set of templates and works. And I've talked to others that say, give it a try. And if it's not finished, that's okay. But, try a lot of different things. How do you feel about that?
I think I'd probably go more towards the second one. I'd rather see a portfolio that has, different projects shown than a portfolio that has the same project repeated, done beautifully, but it's not showing me anything else. And I guess from our perspective, something that I know the hiring managers look for is the journey. So what steps have you taken? They really like to see, I guess, quite granular detail and proof of what you've actually done and what your part was. I think I quite like to see when people talk about the team. So the team did this, but my role was this in particular. But yeah, I think in a portfolio is very much like a CV. It's you on a page. So don't be afraid to put some personality in there and highlight your skills and it's your showcase. So yeah, show off what you can do.
I'll ask this one for Samuel. He says, when it comes to interviews, how should I approach for when I start getting interviewed at AI-related jobs? It sounds like a little bit of a preparation question there.
Preparation is key for any interview. I think do your research on the company, hit LinkedIn, find out who you're interviewing with, try and get some common ground. It might even be a case that you're attending the same sort of events as each other, and that's a great icebreaker when you start speaking with someone. And be up to date on what's going on in technology, at the moment and what's coming down the pipeline. Just be able to get that information and show that you've really taken the time to find out about the company and think outside the box. It's all well and good quoting stats of the company and, you were founded in such and such a year, but find out what they do outside of that. And also not necessarily just within AI, talk about their corporate social responsibility, what they do on that side of things, and how they link the two together. Do they use AI for good in that sense? So yeah, just really show that you've done your preparation.
Charlie, it'd be really great. Just we've got a couple more minutes, and I'm happy if someone jumps in with a question. But what are the kind of things you do in your organisation above and beyond just doing great projects for clients? You talked about AI for good. What kind of activities go on in your organisation?
So we've got a lot of initiatives that we run internally. As I mentioned earlier, mental health has been my background, and I've been really lucky in my role at Amy that I've been able to bring that in. So we do a lot looking at our own mental well-being, physical and mental health. So I've seen someone's asked the question.
Yeah, Charlotte's particularly interested in. Sherry. If you've got any examples of that along the way as well, that'd be great.
Yeah, so I saw an article recently, and it's about, I think it was TfL that did the study. It was about using AI to predict suicide, actually, and suicide cases in using the train lines. It was a little bit of a morbid one. And then I did my master's dissertation on suicide in the military, so it's normal for me. But yeah, they were using data analytics and AI and machine learning to predict which stations were most likely to have suicide attempts, and then basically putting in place more support. So you might see at some train stations now, they have the Samaritans number in like a big placard, and putting in more things like that. So that's how they've used AI in that way. And I know from my background in the NHS, it's being used in many ways in there. I can't kind of go into all the details because it's been a while since I was in the NHS. It's probably very out of date, but it's definitely being used and it's at the forefront in many areas now.
Wonderful. And you organise challenges and hackathons as well, don't you?
Yes. Yeah. So something that Steve, our CEO, is really keen on is that we're not a company that just writes a check. We like to get hands-on and get involved. And so we'll use our team and our expertise to work with local communities to help with things like hackathons and using the technology that we've got at our disposal for good, essentially.
Wonderful. Another question's come in from Olasgun and asking about AI in construction. Now, I'm sure we could get lots of these all night, but where would you point people like him to go and learn more about particular use cases?
I wouldn't know, unfortunately. Not an area I'm very familiar with. Sorry.
No, not at all.
I can try and find out and come back to you.
No, we asked you to talk about hiring, recruitment, culture, and how to get jobs in AI, but you're obviously already being seen as an expert, and hence why.
Smoke and mirrors.
Let's see if we can put some things on the chat for you around the question around construction. And a general question there, but one from Abdul again. Just advice to a graduate who's looking to get a job in this field. What would you say to them?
Keep your options open. Apply to more than less, but also don't overdo it. So I spoke to a graduate a few years ago now, and he was getting quite disheartened. He said he'd applied for hundreds of roles. And I did kind of use the old, it's quality, not quantity. Really tailor your application, do a cover letter, reference the company and the role, let them know that, make it them feel like this is the only job that you're applying for. This is the only job that you could possibly want, and that you're perfect for it. Use the job spec to make sure you're highlighting your skills in line with what they want. So pick out those really key characteristics and traits and skills that they're looking for. And don't be afraid to follow up. This year in recruitment, I'm part of a internal recruiters network, and we've been inundated, hundreds and hundreds of applications per role, and it's difficult to go back to everyone. So don't be afraid to follow up on your application, because if I've received 100 applications over 2 days, but then you email me and say, I just wanted to check you got my application, then you're going to go straight to the top of my list. Don't be afraid to follow up and ask for feedback. If you get a polite rejection, ask for feedback. Ask to say, I want to improve on what I'm doing here. I want to know how I can be more successful in the future. And LinkedIn, I think, is a great tool to follow companies. You'll see when they advertise roles straight away. And use your network. Then coming to things like this and building out your network is perfect.
Amazing. Shah, thank you so much. Please show your appreciation with me for Shah. You can put a little emoji up or say thank you in the chat. We're very, very grateful. And I love your advice as well. When I was in my my postgraduate days, I interviewed with the BBC. And those who are in the UK will know this. It was for the sound effects role on The Archers. How crazy is that, right? and yeah, right. And I didn't get it. Nisha, let's see if we've got time for your question in a second. I didn't get it. I followed up with them, and I ended up spending 2 days shadowing and learning all about what was going on at Broadcasting House. It's amazing, just from saying, can I have some feedback? That's what I said. Nisha, one last quick question for Shah?
Yes, I'm doing my MBA at the moment, and it's now being more tailored around AI and the influence. What do you think about it with the global marketing that's really happening at the moment, and where's AI really going in that field?
Well, probably one I'd best leave to someone else, unfortunately. I should have started off by saying I'm the least technical person in probably the whole of the UK right now. Even my 5-year-old's better with technology than me. But yeah, so apologies, Nisha, I'd have to leave that for someone else to answer, just to do the question justice.
Okay, thank you so much.
Thank you.
Sorry, I hope I set the scene with Shah. So she's the hiring manager across all the business, all roles, from everything, from the secretary to the director to the practitioners and everybody in between.
I don't want to disturb. Is it possible, is there anything for anybody with an MBA eventually and an events management degree in your business, Charlotte?
Not at the moment, but if you find me on LinkedIn, let's have a chat. We can keep in touch.
Okay, definitely. Thank you.
Thank you. I'll keep an eye out for you.
Okay, Nisha Augustine Matthew. Okay.
Wonderful. So Zoe's raised her hand to say, are we going to get started tonight? Is that why you've raised your hand?
I also have a question, actually.
Oh, okay.
So do you look at like age or formal degrees in terms of like university degrees or stuff when you're hiring?
So we actually do, we actually do blind CVs. So I'm the only person that will see that information. And then when I send CVs onto the rest of the team, any reference to age, name, gender, ethnicity, education is removed, because we're trying to make sure that we have as diverse a workforce as possible, and that's been proven to have a really positive impact on that. So we very rarely have any roles where it's a must that people have a degree. Even in our highly technical roles, it's actually quite a mixture as to who have got degrees or higher education and who have got what they like to call the University of Life and have kind of learnt on the job from apprentice level upwards potentially. So some of that information might be important, but we try not to make that the be all and end all when we're looking at applications.
Wow, what an amazing process. Does that answer your question, Zoe?
Oh, sorry, I was muted. Yeah, it does. Thank you, Charlotte.
Wonderful.
Thank
Well,
you.
since you're at the very top of my screen now, why don't you tell us what you've got in store for us tonight over the next 90 minutes?
Me?
Do you want me to introduce you first?
Oh, no. I just, because I thought, is Charlotte not doing a talk?
So Charlotte's been doing the Q&A with us. So
Oh, okay. Okay, that makes sense. Yes.
Char,
So, hi, everyone.
Sorry, 1 second. Do you have to go, Char?
I will have to shortly. Yeah, I've got the little one in the background singing.
No problems. Okay.
I'm going to stay as long as I can because I want to learn. So I will nip off at some point, but I'll be here for now.
So we'll close the questions then with Char just right now, and I appreciate some more coming in. But she'll answer them on chat if she can. But obviously you can hear if she's got children to look after and so on. But otherwise, do find her on LinkedIn, and she can direct you appropriately as well if you want to continue talking with her and find out more about Amy. They're an incredible company, as you can tell by hundreds of CVs per role. Wow. Thank you again. And Zoe, you're leading tonight. So do you want to introduce yourself, or should I do it?
Sure, I can do it. Hi, everyone. I'm Zoe. So I'm really interested in learning about AI, specifically the applications of AI and in the field of biology and bioinformatics. And what else? Yeah, that's pretty
Launched
much
your not-for-profit.
Yes, and I launched a nonprofit to teach other people about AI and biology, and specifically to increase gender diversity in the field of AI, because I noticed that there isn't really much, but I'm seeing that there's a lot of women here tonight, so that's good to see.
Excellent. So we're on our 3rd chapter now of this, and we're talking about NLP tonight. Do you want to set the scene for us on that?
Yeah, so before we start, I saw on the WhatsApp that a lot of people were saying something called neuro-linguistic programming or something, and that is not what we're referring to in this workshop. We're referring to natural language processing. So yeah, so anytime you hear NLP, just think natural language processing. And we're going to be going over what exactly NLP is, how it relates to AI. It's not like a technique or anything. It's like this kind of subfield, and we'll figure out how to do certain tasks in NLP, and then we will close it off with a fun quiz and a nice activity.
Sounds fantastic. What do you need us to know or do? What are your expectations of us, the audience?
Yeah, so participation is great. I'll be asking questions throughout the workshop, and I mean, it's just more fun for everybody if people just chime in. And then in the quiz, I would like 100% competitiveness. We don't want any slackers here. So yeah, okay, that's pretty much it.
Great. So should I give you controls then? Are you ready to go?
Yep.
Can we get a background on you, please?
Sorry?
Can we get a little bit about your background, what you're doing, and what you're...
Yeah, so I'm a high schooler from Chicago, and I got started in AI my freshman year of high school. I was just really interested in learning about how you can have a career in biology without actually being a doctor or a bench scientist or something, and that's when I found out about AI. And so I really just read articles, did Coursera courses and everything, and I was self-taught. And yeah, and then I'm just trying to teach other people by making it as easy as possible to learn, because I noticed that a lot of AI courses and articles have really complex math concepts, or they assume that some coding skills that you may not know. So I'm just trying to kind of lower the barrier and make it easier for everyone to learn. Does that answer your question?
It sure does.
Perfect.
Thanks, Dean.
I thought you were in graduate school.
Oh.
Zooey makes us all feel old, but we bless her for it, and love to see the enthusiasm and the knowledge that she brings to this. And of course, we're supported by a great team as well. And it's so good to see Violet here as well, who does give us that PhD in AI and years in the industry. So she always gives us a wave if we need her to steer the ship a little bit as we go through it.
Yeah, I know nothing about NLP, so I'm
great.
studying tonight.
We're in good company tonight then. Excellent. Zooey, you've got controls, so I invite you to begin the session.
Perfect. Okay, can everyone see my screen?
Yes.
Yes. Cool. Okay, so if you have any questions, I forgot to say this, you can either drop them in the chat or just unmute. I currently cannot see the chat, so it would be better if you could unmute. Okay, cool. So as I said earlier, today we're going to be learning about natural language processing and what it is, how to use it, and some activities in it. So first of all, what is NLP? So NLP is a subfield of AI that focuses on programming computers to process linguistic data. This can include spoken word, written word, anything that has to do with words. And if you guys came to the earlier workshop, the one that was right before this, it was on computer vision. So that was all about how to make computers see images. This is all about how to make computers understand language. So NLP, as I said, is a subfield of AI. It's not like a technique or anything, and it has multiple applications. So some really common ones are chatbots, like that you see if you go on like an e-commerce website or something. There's sentiment analysis, where you can like categorize texts and tweets or Facebook posts based on if they're happy or mad or sad or scared or something. And sentiment analysis can be really important in everything from like gauging customer satisfaction to like to allocating resources in like disaster relief, because you need to categorize tweets by the matter of urgency or like what they're asking for or so on. It's also important in translation. You can use NLP to translate from any languages. Google Translate is made up of NLP techniques. Autocorrect, like Grammarly and stuff, uses NLP. And speech recognition, or Siri, Cortana, Alexa, they are all a part of NLP as well. So as you can see, it's a really broad field, and its applications are endless in our daily lives. So before we start, we need to establish something that computers can't read. Words as we see them, they can't like see words as such. So in order for computers to like do anything with words, we first need to convert them into vectors. And if you guys came to the workshop right before this, we saw how we needed to convert images into like pixels. So in kind of the same manner, in a parallel manner, we need to convert words into vectors. And this is done using feature extraction, and it's also called feature encoding. I apologize, the text is a little bit wonky there. So feature extraction and encoding is basically the technique to convert words into vectors. And there's a couple of different ways to do it, and we'll see how they go from like not that complex to complex. And then we'll also see how some of the words or some of the techniques have a lot of limitations, and some of them are like really powerful. So right now, does anybody have any questions just starting off?
Are you going to tell us what each of these three things are or not?
Yeah. Yes, I am. We're going to go through each of them. Okay.
I have a quick question for you. When a car reads signs, an autonomous vehicle reads signs down the road, is that just computer vision, or does it need to use NLP to work out what's being written on the signs as well?
That's a really good question. I'm not really sure, because would it be like, and Violet, you can also give us your input, because I think, would that be like a combination of NLP and CV, or would it be like purely CV where you can just, even though it is words, like you're still doing it by like the images, like how?
Yeah, I think the range of things that it's reading is so limited. If it's place names, then it's not really about sentences and how the words in the sentence relate to each other, which is what NLP is mostly about. It's just recognizing individual words or very specific road sign things that are relevant to a car.
Yeah, it's more like patterns.
Mhm.
But that's a really good question. I didn't think of that.
Thanks.
Okay, so as I said earlier, we're going to go through a few techniques in which you can do feature extraction and encoding. And yeah, we're going to do some quick activities that will hopefully be really fun. So the first technique to do feature extraction or embedding is called one-hot encoding. And for people who have a background in computer science, this may seem familiar to you because I think it's also, and I have like not that much experience, but I think it's like also used in like programming computers. I'm not sure. But when I was doing some research, I think I heard about that. But basically, in the context of NLP, you use it to encode categorical or written variables, which is basically words, as a binary variable, so 0 or 1. And this definition may seem a little confusing, so we're going to go through an example later. But basically, the value matching the variable is encoded with a 1, while every other variable is a 0. So let's go through an example. So for example, if we're going to one-hot encode this sentence over here, red cat eats blue fish, let's go through how we would do that. So first, we need to create a vocabulary. And a vocabulary is every unique word in a text. And my text over here is this sentence. So this is my vocabulary. And now we're going to one-hot encode each, we're going to one-hot encode the sentence, and we're going to iterate through each word in the vocabulary. So what we're going to do is first we're going to go through the sentence and see which of these words match with the first word in the vocabulary. So obviously the first word matches the first word in the vocabulary, but the rest of them don't. So it'll be 1, 0, 0, 0, 0. And then we'll go through and we'll find which one of the words matches the second word in the vocabulary, and then the third, and so on. And then we generate this series of vectors where it basically shows, hey, like this word in the vocabulary is present in this position over here, and so yeah, so basically that's how it is. And in this sentence, I only had the words appear once, but if I had like the red cat eats the blue fish and the red steak or something, then that one would appear more than once in that vector. So does that make sense?
It does for me.
Zhui, have you used or heard of indicator variables?
No, I have not.
I think of one-hot encoding as similar to statistical ideas of indicator variables or dummy variables. And basically in statistics, you might say, well, here's a male or here's a female. Is it male? Yes or no, 0 or 1. Is it female? Yes or no, 0 or 1. And it's same sort of idea for the one-hot encoding, except you're sort of counting as well as indicating whether it's true or false.
Yeah, I've heard of dummy variables, so that's really cool how it like, there's a lot of parallels between AI and stats. So that's really cool.
I think the distinction between one-hot encoding and indicator variables is that one-hot encoding is like the whole collection of all possible indicator variables for all possible words in your vocabulary, but only one of them is ever allowed to be on. That's the one-hot bit. So a word can't be both red and blue at the same time.
Yeah, I agree.
So it's a collection of indicator variables, but with a restriction that only one's allowed to play each time.
Yeah, that's a really good point.
Good point, thank you.
Okay, so now we're going to apply what we just learned, and we're going to see if you guys can create a series of, not like every vector because this sentence is kind of long, but just 3 vectors for these 3 variables. And then you can type it in the chat using one-hot encoding. And this is not the quiz, so I don't expect full competitiveness here.
Why, thank you.
Yes, no problem.
Okay. So you want us to do the vector, it's open brackets, and then the either a 1 or a 0, depending on whether or not that word is in where it is in the sequence in the sentence.
Yes.
Okay, cool.
And there would be a lot of zeros in this vector, so just like put a random number of zeros in there, like I'm not gonna count. Like, do you know what I mean? Because there's like a lot of words in here. Or if you want to count, you can count them. Oops.
Ooh.
Sorry.
Zoe, so you can see it. You should be able to have it as a floating box on top of your screen if you go full screen.
Yeah, oh my goodness, you guys are actually counting them out.
Yeah.
Oh yeah, so all of these words are technically vocabulary words, but if we went through every single word, like every single unique word in this sentence, we would be here for like hours. Or not hours, but like a pretty long time. So I'm just gonna pick the 3 words to answer Sherry's question. Okay, I'm sorry guys, these vectors are so long.
Are you going to put us out of our misery?
Yeah, I mean, if you guys like get the gist, then you don't have to like actually count out every 0.
Yeah, I don't, from what's appearing in the chat, it doesn't look like they have.
Sorry?
It doesn't look like they've got the gist of all the attempts in the chat.
I mean, it looks good to me.
So if your vocabulary only has 3 words, then
no, my vocabulary has technically, okay, so sorry, I should have clarified. So technically the vocabulary has every single unique word in this sentence, but I only wanted you guys to make vectors for the 3 of them. Because otherwise we'd be making vectors for a long time.
Yeah, so it's 0 for Annabelle, 0 for wanted, 0 to wear, 0 for her, 0 for red, 1 for coat.
Yeah.
Yeah, I'm with Abdul. If I understand that the way I understand that the slide is written, the vocabulary only recognizes 3 of the words, so it has to skip all the other ones, and you encode them in the order that you've listed the vocabulary. So when the word coat appears, that's 100. Right?
Yeah. But
word red appears, that's 010.
Yeah, I mean technically, but I mean I was implying that the vocabulary has more words. It's just I didn't want to list them all out because there's a lot of them.
But they all come later, after these ones.
Yes.
You have to know the order of your vocabulary. So if you like put a ... after the 3 that you've listed.
So okay, so I thought that we were looking through the sentence and writing a vector for coat, and then a vector for red, and then a vector for green.
Well, except the word red appears before the word coat in the sentence.
Yeah, but the word coat appears before the word red in the vocabulary.
Yeah. So
this is what I was looking.
Oh, okay. Let's see the answer.
Okay. So Annabelle is technically in the vocabulary, but it's not what we're looking for right now, because right now we're looking for coat. So 0, wanted is 0, 2 is 0, wear is 0, her is 0, red is 0, coat is 1, and then everything else is 0, 0, 0, 0, 0, so on. Okay?
That's not how I understand one-hot encodings to work. So the length of the vector in a one-hot encoding is the size of the vocabulary. So if your vocabulary has 3 items, then each word gets encoded as a vector with 3 numbers in.
Yeah, but what I'm saying is the vocabulary doesn't have 3 items. It has more than 3. I just didn't list them all out.
Right. So that's what I mean about the ... dots that come after the coat and the red and the green. But coat is the first thing in the vocabulary. So when the word coat does appear, it is encoded as 1 for being coat and 0 for being anything else. So lots and lots of zeros after that. But that is the encoding for one of the words, not for the whole sentence. Each word is encoded as a vector with lots of zeros and 1, 1. Yes? No, maybe?
Sorry, I'm a little confused about what are you encoding one word?
Each word, I am one hot encoding.
Yes.
So instead of having like brackets for the whole like sentence, 3 sentences for each one, you would have each sentence, the bracket that we see is actually the bracket for quote. And then we have like all of the brackets. We would have actually 26 brackets sentence. Is that what you meant, Violet? Is that every word is actually in brackets?
Yes.
And then
chat,
it's the addition of brackets.
I can see Abdul's attempt, and that looks to me the same as I would understand one hot encoding to be. So the first word that you encounter that appears in the vocabulary, everything else you'd have to encode as zeros and then some ones somewhere later on that you can't see. But the first word you recognize is the word red, but in the vocabulary it's the second one on the list. So you put a 1 in the second position, so it goes 0, 1, 0. The next word you recognize is the word coat. In your vocabulary, that is listed in the first position, so you encode it as 1, 0, 0. And then I think the next one you recognize is green, and that's third in the vocabulary, so that's encoded as 0, 0, 1.
So is that
Violet.
what I've just put in the chat, Violet? And the dots are actually the other words in the sentence.
Yeah. But actually, for a longer vocabulary, each of the angle bracket vectors would have more items, but they would, the ones you've missed out will all start with at least 3 zeros, and the 1 is somewhere further down. Does that make sense?
The way I understood this question also is the vocabulary was only 3 words. In a sense, they had reduced the number of features beforehand, knocking out the words Annabelle wanted, because, for example, maybe they weren't relevant to the meaning that you're seeking, or the questions that you're answering are more relevant to coat and the word red and green. And that's sort of a feature reduction type of thing that I've seen.
You cannot encode them with this vocabulary. They're not in it.
Right.
Yeah.
Yeah. Okay. So I think what some people are saying is that because the vocabulary only has 3 words, you would skip to the words like as they appear in the vocabulary, which does make sense. But that was a mistake on my part, where I should have said that I just, like, the vocabulary has every single word. So it has Annabelle, it has wanted, and so on. So because it has every single word, you would add like the zeros in the beginning until you get to red. But I didn't want to like write down every single unique word. But I guess like what you guys explained is also correct. It's just we interpreted the question 2 different ways.
Yeah, but in order to know how to encode Annabelle, you would have to know at what position it appears in your vocabulary, and we don't know that because we haven't got a full listing of the vocabulary, so we wouldn't know where to put it.
And okay, so I think there's also some questions in the chat. So duplicate words, as long as it's the same word, you can put a 1 twice. If there's her twice, put a 1 twice, because you're trying to figure out where it is located. And then what determines where the hot bit appears? So you basically take a word in your vocabulary and you try to see like if it matches each of the words in the sentence, and when it does, that's the hot part. So that's where you put the 1. Does that make sense?
It may be easier to understand it if you say it the other way around, that you take each word in the sentence, you look down the list in your vocabulary, and when you find it in the vocabulary and it's in the 27th position in your dictionary, that's the bit you light up. You light up that it was the 27th word in the dictionary.
This is where I find indicator variables to be a more common sort of representation, or easier for beginners to understand. It indicates that there is a coat, there is a red, there is a green, and you may be able to say yes or no depending on the sentence, or even count them up. But it indicates whether something is there or not. Would you agree, Violet?
Yeah, this is slightly different purpose. So if you're talking about presence or absence of something, then you could merge multiple of these one-hot vectors into one to get, for example, a set of all the words that are present in the sentence. But that's just for a slightly different purpose. But basically, the reason you turn them into these vectors rather than indicator variables that tend to have a specific meaning associated with them is that once your dictionary gets very big, you can't list them all.
But for the purposes of teaching the idea, I think it's easy for people to sort of understand the indicator. Just a generality, overgeneralization, I guess, is what I'm sort of discussing or suggesting the understanding come from.
Okay. Healthy debate and perspectives are always what make up who we are, and it's a reminder that there's multiple lenses to see through the world. But I thank you so much for your input, Violet, into that area, trying to make sure that we say things as exactly as they should be. Matt, thank you for leaning in as well. But Zui, command of the room, back to you most definitely. And I appreciate that you were presenting something in a way to make sure that we could comprehend. For those in the room with an IQ of about 105 like me, that's very much appreciated. So let's keep an eye on the clock, and let's learn from this, and let's have a little check-in afterwards to see that we make sure that we can learn from it. But otherwise, let's push on and let's keep learning. How does that sound?
Yeah, that sounds good.
Great.
Okay. So is the order of indicators, there's some questions in the chat, so I'm just going to answer them. Is the order of indicators determined by the words in the sentence or the order of the vocabulary? So I think what you're saying is like, which word do you look for first? That would be determined by the vocabulary. So if coat comes first in the vocabulary, then you would look for coat in the sentence first. And then you don't understand the clarification. Oh, okay, yeah. So it's not really, it's kind of like a semantic, but you just said if the word matches a vocabulary word, then place a 1. So I just like added, like, it would be like the specific vocabulary word that you're trying to match currently. But yeah, it's like you basically got it. So, and then to kind of conclude this slide, we found out that there were 2 different ways of looking at this question. Either way, as long as you got that when the word matches the vocabulary word, you put a 1, and everywhere else you put a 0, that's basically the gist. So is everyone good with that?
I am.
Okay, sounds good. So, oh, my text is still there. How do I take that off? Okay, so we learned about one-hot encoding, but it does have some limitations. First of all, it's very computationally expensive. If you think about it, right now, our sentence only had like a few words, but we still had to write so many vectors and we had to type so many zeros. Imagine if you have a corpus, and by the way, corpus means a body of text, with 20,000 unique words. Each text in that corpus would be represented by 20,000 vectors, and that would be a lot of vectors and a lot of zeros. So that's just really computationally expensive, and we're trying to find something that's a little bit less tedious. And then also one-hot encoding doesn't capture the meaning of the individual words, or it doesn't capture like relationships between words. You only know if the word is there or not. So that is a problem with one-hot encoding, and you can't really use it for like translation or anything, because if you don't even know what the word means, you just know it's there, then it's not very useful. So just to clarify, corpus means collection of text. And this is a vocabulary word that will be in the quiz if you guys want to write it down or something. And it's kind of important to the field of NLP because I guess like in AI in general and in stats and everything, we call like the data a data set, but for some reason the data in NLP is called a corpus, which is kind of cool. So the second feature extraction or embedding approach we're going to talk about is called bag of words. And it's kind of like a step up on, yeah.
Sorry to interrupt. The screen that I can still see is still showing one-hot encode the sentence. Did you want us to be on a different slide?
Yeah, sorry, I don't know why it's...
Bag of words come up now.
Can you see it now?
Limitations of one-hot encoding.
Okay.
So this is the limitations of one-hot encoding that is on the screen now.
Okay, perfect. Yeah, so I just went over that and then clarified corpus is a collection of text. Okay, so now we're going to talk about bag of words, and it's kind of like a step up on the one-hot encoding model. And so this describes the occurrence of words within a document, and it creates like this one like giant vector where it's like every single time that word occurred in that document. So there's not as many zeros. It's like a non-zero vector. So that's fun. And it involves two things. So a vocabulary of known words, just like we had a vocabulary in our one-hot encoding example, and it has a measure of the presence of known words. That's basically the point of bag of words. It's like, how many times does this word appear in this text? So why is it called a bag of words instead of like a line of words or something? It's called a bag of words because any information about the order or structure of the words is discarded. So it only cares whether the words are in the text, but not where the words are. So for example, this is good and is this good would have the same bag of words vector, even though they mean two different things. Like this is good is a statement, but is this good is a question. Does that make sense?
Yes.
Okay, because it has the same exact words. So how it works, you collect your data, which is in the form of words, so your corpus, and then you decide on the vocabulary. And for this, we're going to do every single word in the corpus, just so we don't have the same confusion. And then you can create your vectors. So like I said earlier, this is basically using one-hot encoding, but it's taking it one step up. So your vectors are one-hot encoded, so you guys will hopefully get another try to one-hot encode vectors in this example as well. So let's start with collecting our data. I chose to use A Tale of Two Cities by Charles Dickens, but not the entire book, just the first 4 lines. And in this case, our entire corpus would be these 4 lines, where each line is a separate text. So if we're thinking about it like in terms of a corpus of books, each of these lines would be like its own little book. And then the corpus would be like the entire library. Does that make sense? Okay.
Yes.
Mm-hmm.
So now let's design the vocabulary. And like I said earlier, we're going to make it every single unique word instead of, oops. Well, okay, let's just, okay, sorry. Yeah, so we're going to make it every single unique word. So these are all the unique words in the vocabulary, and you can count them if you want. Okay, so now we're going to go through each text and create a vector that represents the occurrence of each vocabulary word in that text. So for example, you guys, I just created one for it was the best of times, but if you want, you guys can go down and write down on a paper or write down in chat the vectors for the other few texts. So I can display that slide later. But for example, for it was the best of times, this would be the vector because this is the vocabulary and this is my text. So it, yes, was, yes, the, yes, and so on. And as you can see, this is basically, so basically what I did is technically for each word, it would be its own little vector, but then you add up all the vectors to get like I said, a non-zero vector that represents the entire text. And that's like how many times those words occur in the text. Does that make sense?
Can you say it again for me?
Yeah. So as we learned with one-hot encoding, we only go through the text with one word to start with. And then we get like a vector that has 1, 1, and then a bunch of zeros, right? So you do that in bag of words for every single word in that text. But then you have to add up all of those vectors to get your bag of words like feature vector, and that vector is represented over here. So that has a lot less zeros because it's basically seeing if like every word that is in the vocabulary is in the text. So then this is even less, I guess, like specific than one-hot encoding because like these ones could all mean the same thing or they could mean different things.
We've got a question in the chat about repeated words.
Okay, so if the words are repeated, so for example, if it was like it was the best of times and then it was the best of times again, then it would be 1 1 1 1 and then 1 1 1 1 again. Does that make sense? Like if it's there, just put a 1.
I thought you said you were counting them. So if it was the best of the times, then the appears twice, and so it would go 1 1 2 because
Yeah.
the appears twice.
For the
No,
feature
wouldn't the
vector,
dimensions of the vector increase? So it'd be like a dimension. If it was the best of the times, wouldn't the vector dimension have one more
No.
element to it? And have another one?
Dimensionality of the vector is the size of the vocabulary.
yeah, so the vector dimensions wouldn't increase, but you would have more like of those individual one hot encoded vectors, like I said earlier. So then when you add them up, as Violet said, you would get like 1 2 1 1 or 1 3 1 1 or so on for repeated words.
When you say add up a vector, do you mean if there is one occurrence of a 1 in a vector, then the value against the dictionary is a 1 itself, which results in this 1 1 1 1 0 0 0, because the first one hot encoding for the first element did exist, which is why the first element in the vector you've got on the example is a 1. Is that what you mean?
Sorry, can you repeat the question? By adding up.
So what I'm trying to do, take your sentence. If the first word is it, using your method in the last slide, you had the first 1 would be a 1, there'd be lots of zeros afterwards. But now looking at what we've got here, you've got a 1 next to the it, because in that vector for that single word, it appeared at least once. So if it appears at least once, does that result in the first one in your example in yellow?
Yeah, and then I kind of skipped a few steps here, so you're right.
Yeah, I'm trying to bridge that gap, yeah.
Yeah, sorry about that. So you're right, the vector would be 1 0 0 0 0 for it, and then for was, it would be 0 1 0 0 0 0, and so on. And then I basically added up all those vectors to create the bag of words feature vector, which is over here.
I think it was the add bit.
Do you have another example, Zoe, where the words in the sentence are not in the same order as the words in the vocabulary, where all the ones are not all together in a clump at the beginning? I think that might help to explain what would be the vector for the second sentence.
Okay, I mean, we can, I didn't really like look to see if that would be the case, but we can try doing the second sentence and see if the ones aren't clumped together.
And I think that might illustrate it better for people.
Okay, so I guess we can try doing, it was, yeah, let's try doing it was the age of foolishness.
Oh.
And just make the feature
ambitious.
Yeah, and then if you want, you can like write down the individual one hot encoded vectors, or you can just skip straight and do the feature vector. Can
you show up the slide with the vocabulary?
Yeah, sorry. Does everybody have the sentence? I mean, it's like 5 words, but you guys have got the sentence?
The sentence is, it was the age of foolishness.
Yes.
Okay, I'll type that into the chat.
This is the vocabulary.
And the vocabulary is, it was the best of times, worst age, wisdom, foolishness.
And then to answer Samuel's question, you can choose whether you want to consider it and it as 2 separate words.
Okay, I've submitted my attempt.
I've tried mine.
Seems I didn't get it. I put 1 everywhere.
1 0 1 1.
Yeah, I just got it.
1. Okay, Bridget, I just think you miscounted, but I think you have the right idea.
Yeah, I think Stevens is the same.
Okay, so
I think Bridget, you just missed 1 at the beginning.
1 1 0 1 1
Yes, I think I missed the.
Okay. Yeah, I think you guys got the idea. And Nelia, did you also get the idea now after seeing everyone else's?
Yes, exactly.
Okay.
So everyone is put there, and so I was like, okay, thanks.
Sounds good.
That's the idea, you see. When you see this one, when they're not in the same order, then you realize what's going on.
Yeah, does this make sense with also the one hot encoding example and everything? Does that all tie together now? Okay, perfect.
Yay.
Okay, so I just got a question that said, why is the fourth bit 0? So, okay, so the sentence is, it was the age of foolishness. So it was the age. So why is, sorry, wait. I'm doing that wrong. So, like looking at Steven's example, it was the would be 1, and then best is not there, so 0. Of is there, so 1. 0, 0, there's no worst, but there is age. So okay, so the first or the fourth bit would be 0 because there is no times or worst. Does that make sense?
No, I've got a 0 on the fourth bit because there's no best.
Oh,
So
right.
what I
Sorry.
did, I went through the vocabulary and said, is there an it? Yes or no? There is, so that's a 1. That's the first one. The second item in the vocabulary was. Is there a was? Yes or no? Yes, that becomes a 1, blah, blah, blah. The fourth item in the vocabulary is best. There's not, doesn't exist, that's a 0. It's almost like a Boolean representation of each
Well,
item
strictly
in the list.
speaking, they're not Booleans, they're not binary, they're counts. So if the same word appeared multiple times, so if it was the best of the times, then there would be a 2 in there. They're not.
Oh, there can be 2s. Okay, understood. I thought it was just an
There was
occurrence.
an earlier question about repeated words, and then you count up.
That helps. So you can weight the relevance of that word, presumably. Got it. Nice.
Yeah, sorry, I think I just miscounted, but best is also not in the vocabulary, so that's a 0. Or not in the sentence. Okay, there's a lot of different words here. Okay, does this make sense?
I'm happy with it. I don't want to speak for everyone else, but I'm okay with it. Thanks, Siri.
Okay, and if in any way it doesn't make sense, is there any way a certain topic can be explained better? Okay, so you don't need to see the corpus because we're only doing bag of words for one certain text, and that text is it was the age of foolishness. And then we already made a list of all the unique words that were in the corpus, so we basically don't need the corpus anymore because we took out all the unique words and they're on the slide. Does that make sense? Okay, I'm assuming it does now. Yeah, so that might have gotten lost in the chat.
Okay.
Okay, so I'm moving on, and hopefully for the people who are still a little bit confused, it'll sink in later. So hopefully, yeah. Okay. So just like with one hot encoding, bag of words also has limitations. And some of these are that the order of words is not respected, because as we saw, everybody kind of got confused because like best and, or what was it? I think age or something occurred after it did in the vocabulary. So there was like a 1 where like, I don't know, but there was an example where the order did not match the order of words in the sentence. So as you can tell, that is kind of bad when you're trying to discern the meaning of sentences and the meaning of words. So yeah, so bag of words doesn't do that. And just like I did with one hot encoding earlier, or I think I did this with bag of words as well, this is good and is this good would be the same vector. So we can't really discern between questions and statements or like sentiments or basically anything because we just know that the words are there, but we don't know where they are, and therefore we can't like discern the meaning. Does that make sense?
Yes.
And not only can we not discern the meaning of the sentence itself, but not even the individual words in the sentence. So as you can tell, it's probably not very useful for like translation or autocorrect or anything, because it wouldn't be very good. It would just be like, oh yeah, this word's like in the sentence. So yeah. Okay, so now we come to our third technique for feature embedding, and this is word vectors. So word vectors are by far the most powerful technique, and these can capture information about the word's meaning and its context. So word vectors are basically vectors, but instead of being binary vectors, each number in the vector represents a different dimension of the word's meaning. And when these vectors are graphed in a vector space, what's really cool is that similar words have similar word vectors, so their like vectors are close to each other, so you can kind of like tell like how words are related in a corpus through looking at them graphed in a vector space. So we'll look at a graph later, and you'll see how like words that have similar meanings or contexts are clustered together, and I think that's really cool. So in doing that, they can represent, as I said, the meaning and also the context of a word. So word vectors are what are commonly used in like translation, sentiment analysis, basically everything. So for example, as I said earlier, similar words have similar word vectors. So the word vectors for wheel and engine would be similar to the vector for car because all three of those words are related. So because they're related to each other, but they're not really related to the word cat because cat is like an animal and it doesn't have wheels or anything, the word vector for cat would be quite different. So if you graph these four vectors on a vector space, the three like transportation vectors would be clustered together and cat would be like in a different corner. Does that make sense? It's really cool to visualize. I'll show you guys a picture later. So in terms of encoding the features in the vector, as I said earlier, there's vectors are made up of numbers, right? And each number in a word vector represents a specific aspect of the meaning of the word. So how do we exactly get those numbers that represent those aspects? The most common way is to use this algorithm developed by Google called word2vec, and it's used to convert words into vectors, word2vec, vector. And then you can input those word vectors into neural networks to create like the clusters that are necessary for sentiment analysis and translation and text recognition and everything. So word2vec is how you convert the words to their corresponding vectors, and word2vec itself is a simple neural network. And that's like how it was trained and everything has a lot of complex math, so we don't really need to go into it, but basically that is what you use. Okay, so now that we have, there was a picture slide. Okay, here's a picture slide. So as I said earlier, I was going to show you guys a picture of word vectors of related words, and you can see that kitchen appliances are all like in this little region over here, and garden appliances are all over here, and these garden appliances are close to grass, which is also usually found in gardens. And then I guess like decorations are in this corner, bathroom stuff is over here. And then stuff that's like tangentially related to bathroom stuff is over here, but it's also tangentially related to like the backyard, I guess, because it's kind of close to that as well. So you can see how you can model the relationships of the words using their vectors. Does everyone get that?
A quick question. So this number output in the graph, is that the product of the algorithm? So you put these words in and you get these numbers out and plot them?
Yes.
Is that correct?
And then if I had like some way to show you guys the 3 space, I could show you the actual vector, but for now we just see the point.
Do you know the dimensionality of the embedding?
No.
Okay.
I just found the image, but it's cool.
It is cool.
Okay, so you've encoded the features and you got these numerical representations of the words, so now what? So given enough data, like given enough words in a corpus, word2vec can make really accurate guesses about a word's relationship with other words. So like, I can't think of something off the top of my head, but like I guess like my phone is dead versus my daughter is dead would have 2 different meanings. So, and that's based on the word's relationship with the other words. So word2vec can kind of discern the difference between those 2 sentences, even though there's only a difference of 1 word. And then you can cluster related documents together. So that is useful. And then you can also classify documents by topics. So that's kind of the same thing as clustering, like based on what words appear in that document. So these clusters that Word2Vec is able to form the basis of search. That's why Google's search algorithm is so powerful, because it's able to use natural language processing to cluster related stuff together. And then you can like get new recommendations and stuff based on what else it sees. You can use it for sentiment analysis and recommendations, like text recommendations in every field from law to e-commerce in terms of chatbots. So as you can see, it's really powerful. Yeah, and then, sorry, to clarify over here, we can't really show the vectors because I don't have a 3D graph, so the points are the vectors. Okay, so now we're going to go over a quiz. This is the quiz, so I guess eat your almonds and drink your coffee. And
a question in the previous step. Is there any units in the abscissa and the orzonates?
No.
Is there a unit? I mean,
no.
A unit?
There are no units, are like meters or feet, seconds, whatever. There are no units.
If a word is at the right side, there is something that makes sense, or nothing, just puts word like.
No, these are abstract dimensions that are created by the Word2Vec algorithm when it constructs the embedding, and there are a lot more than 2 of them. It's just you can't easily visualize in more than 2 dimensions, so you're only looking at particular 2. But okay. There are no units. They are dimensionless dimensions.
Are we talking about the vectors?
The colored dots that you showed, whether the axes have units associated with them.
Yeah, that's arbitrary.
Yeah.
Okay. Yeah, if you're allergic to almonds, then eat walnuts. Okay, so let's everyone go to Quizlet Live, and I will start the game. Oh, I need to go to Quizlet Live as well. Just 1 second.
This is where we've got to be 100% competitive, right?
Yes, absolutely. Or else you'll be kicked out and you can't do the coding part.
Okay.
So are you going to give us a code? Is this how it works?
Yeah, I'm trying to find it right now.
All right.
I just had it, but I think I closed the tab. Okay, ready? Was that my music? I don't know. You guys want teams or do you want to do it individually?
Hey, let me call you back.
Well, if we're going to be competitive.
Yeah, I think individual is good. Okay. Here's the code. I'll put it in the chat too.
Hey, can you hear me? Hey, can you hear me?
Okay, that music was really loud, so. Okay, we only have like half the people here. Do the other half not want to play, or are you just like slow?
You're on. We can't hear you, Richard. I can't hear you, Richard.
I'll bring my mic across, and how's that?
I can hear you now.
All right. Now we're at 24. Let's go. Let's go. Let's go. Everybody's in, I'm sure, that wants to be in.
Okay. Yeah, you guys can join later.
Just 2 more minutes. 2 more minutes.
Okay. Oh no, I think I
Hey,
ended
Jake, can you hear me? Hello?
Guys, I think I ended the game. Sorry, can you rejoin?
Yes.
Sorry.
Okay. Take 2.
That was just a test.
All right. Now we know how it works.
Yep.
We'll go back
that was
up.
Dean. We're doing this just to fill time for Dean.
Yeah, we were asked for a couple of minutes, and you've been given that now. Okay. 230023. Here we go. Back in. There we go. Easy days. 14. Study while you wait. 17. Excellent. What did we get to last time? 23, was it?
I think this quiz is cumulative, so there are some questions from earlier workshops, but there's not that many, so if you didn't attend earlier workshops, then you're okay. But most of them do focus on what we learned today.
Okay. We've got some bad background noise off someone's mic, just for what it's worth. Whoever's not muted is, yeah, quite a lot of background noise. Okay. Should we jump in?
Yeah, let's do it.
All right, let's go.
Join in the middle of the game if you your computer's not loading or something.
All right, here we go.
I'll start the music now. The alpacas in the lead, followed closely by the rhinos and the tigers. Hey, the alpacas won. Who is tigers?
Can you see that?
Are you alpaca, Richard?
You see what it says?
No. What does
It
it
says
say?
you are in last place.
Oh.
I was having some technical problems, most of them
Okay.
inside my head.
Okay, so do you guys want to go
Violet? Violet wins again.
Yeah, congratulations. Okay, so should we play again and then we can go through what we learned, or do you want to do that right now?
You choose. You guide it, okay? You're in charge.
Okay, so I guess let's just go through this really quickly. So, first of all, what we learned is that one-hot encoding and vocabulary are two different things, and one-hot encoding is where you represent categorical variables as binary vectors, and vocabulary is every unique word in a corpus. Excuse me. And then bag of words and vocabulary. Oh, I get how this might be confused. So, as I said, vocabulary is every unique word in a corpus, and bag of words is it's a feature embedding technique where you represent the occurrence of words within documents with vectors. So I think we were getting vocabulary confused with different feature embedding techniques. Just like if you feel yourself getting confused, just ask yourself, is this a feature embedding technique or is it just like a name for something? Okay, and word to vec is a feature embedding technique, so I guess I can see how you guys would confuse it with another feature embedding technique, but just remember that word to vec is not a binary vector. The vectors, the numbers in the vector represent different meanings of the word. It's not binary. Okay, and then this was from an earlier workshop. So vocabulary and weights are two way different things. And this might have been like a misclick or something. I don't know. But weights represent the, they transform the input data to improve the accuracy, and vocabulary, as I said, is every unique word in the corpus. And training data and weights. Okay, so this is like self-explanatory. You guys can just read this. Okay, you read it? Cool, let's play again.
Okay, do we have to have a new code?
No, it's the same one.
Did Shalom get the code though? I think somebody was missing.
Yeah, were you able to rejoin?
The code is 230023.
Oops. Sent it here.
Oh, there's background noise? Here, let me try muting. Okay, is it better now?
Do you want to check your mic? You might have switched to a different mic. You were fine, and now you're on a mic with white noise attached to it.
Okay.
Or unless you've got a fan in the background or something.
Oh, it's probably my computer fan.
Okay, mystery solved. All right.
Sorry about that. It's supposed to be a new computer, but it acts like an old one, so.
All right, ready?
Yep, let's start. Oh, not everyone is ready.
See, Ham, you just got to go to Quizlet.live, punch that code in on your mobile. Or your browser, I guess.
Oh, I haven't started the game yet, so maybe you might want to refresh.
Yep. Waiting for the game to start. That's where we're at. Okay, well, sorry to those who can't get access. It is free and it is available. So let's make it rain.
Okay, cool. So sorry, John, Cena, and Fiona, and Onkar, and Himanshu. But we are starting. Have the same score right now. Oh, but the Tigers are taking the lead. Oh, but the Tigers got something wrong. Dandy, congratulations! And who was everyone else?
Let's not check too much detail.
Sorry?
You know, let's not dredge up the past of who came seventh or anything like that.
Okay, congratulations to Dandy. And since these, oh, there's only one takeaway? Oh, what we should study, let's go over that. So, okay, so bag of words and one-hot encoding was frequently confused. And think about it as bag of words is basically a bunch of one-hot encoded vectors added up. Okay, weights and word to vec. Okay, so this is kind of cool because word to vec uses weights in its neural network, but word to vec is not a weight. Does that make sense? Because word to vec is a neural network, so there are weights inside of word to vec, but it is not a weight itself. Okay, and testing data and training data is self-explanatory once you understand it, so you can just read that. Okay, cool. So I was happy with the level of competitiveness, so everybody can stay. And now we're going to move on to the coding portion of this workshop. So what we're going to be working on is, oh, I had a cool animation. Okay, so we're going to be working on sentiment analysis. And we're going to be working on sentiment analysis of movie reviews. So, yeah, so that's cool. And this is really flexible, so if you want to code some parts yourself, there's basically like a framework, and you can either delete sections and then see if you can recode them, because it's basically all coded right now, or you can just follow through as we explain using a participant screen how they would go through and understand that code, because that's what we've done in earlier workshops. So either way, just click on this link. I can post a link in the chat. Just give me a second. And make a copy of the notebook so you can edit it however you want, add comments, do whatever you want. And yeah, and then we can go through it. And do we have any volunteers to share their screen as they go through the notebook?
Nilla, do you want to share your screen?
Thank you, Bridget.
I know. Do you have any volunteers? I'm not sure.
Hey, Nella, who has a problem every time with the collab. Would you like to come up? Yes, I can share my screen. Yeah.
That's what you get for being the top student.
I'll stop sharing. Okay.
Okay, let me just share that. Jeff. Okay. Collab. My computer has decided that it's too slow for the yeah, maybe no, it's
okay, so
yep, that's perfect.
Yeah, that part I had. Hold on, I think I need to. Do you see the new page, or are you still on the other page?
No, I can see the new page.
Okay, cool. Slowing. Okay.
I hope I was muted just now.
So what should I do now?
Okay, so just run the first cell first. And this is like some prior setup. This doesn't really have anything to do with NLP, but you just need to set it up first to like download NLP. Okay, so press D. Okay, and then the package we want to download, I think, is called Movie Reviews, but let me check the spelling. Yeah, it's called Movie Reviews, and it's all lowercase with an underscore in between movie and reviews. Okay, and then just press quit now, because we're done.
What?
So just a Q for quit.
Okay.
Okay, so now that we have movie reviews downloaded, you can press the next cell.
So can you explain just a little bit what is movie reviews? It's just for us to, it's the file that we're going to use to extract the words from movie reviews, or?
Yeah, so do you remember how in the very first workshop, we took our data from the Yahoo like stock page? Like stock
Yes.
Yahoo. So today we're taking basically a corpus of movie reviews from the library called NLTK, and we're just importing it.
Okay. So I've run the second one. Did it work?
Okay. Yeah, you won't get anything as long as you don't get any errors. You're perfect, because you won't get anything because you're not printing or like showing anything here. So this is perfectly fine, and what you're doing there is you're basically defining a feature extractor for documents. So the classifier will know which aspects of the data it should pay attention to. So for example, the features over here are movie review words, and then categories, and then categories. Yeah. So, and then, yeah, so that's pretty much it, is what you're doing in that cell, the third cell over here. So if you run the third cell.
This one, define the feature extractor. Yeah.
Yeah.
Is that taking the top 2,000 words that occur in there?
Yeah.
Top, the 2,000 most frequent words.
And then you're basically making that your feature extractor.
Sorry for the cat.
So now we're going to use the feature extractor in the next cell. We're going to use a feature extractor to train a naive Bayes classifier to predict the sentiments of new movie reviews. So let us pause and clarify something. So as I said earlier, NLP in and of itself is not an AI technique, it's a field. So you have to use AI algorithms in NLP. And one of the algorithms we're using is naive Bayes. And as you guys probably know, naive Bayes is really common in like text classification. The most common, or I guess like the most common use of naive Bayes that you guys may have heard of is classifying emails as spam or not spam. So in that sense, it is pretty good for NLP. So we are going to create a training set, as you can see over here, and a testing set, as you can see, from our feature sets. So that is what that second line over there is doing. And then we are going to name our classifier, and we're going to import it from naive Bayes, and we're going to train it on our training set. So this is basically what we did with our linear regression when we did our coding earlier. Does that make sense?
Yes. So basically, we're going to try to find two categories with those movie reviews. One could be like one movie review is good and the other one is bad. Is that right?
Yeah.
Okay. So we're doing like a tomato thing, like Rotten Tomato, whether it's a good tomato or bad tomato, right?
Yeah. Yeah, exactly. And then you're going to try to predict with new movie reviews that you've never seen before if it's negative or positive, the review.
Okay. So should I run the train naive Bayes?
Yeah, so what this does is it trains the naive Bayes, and yeah.
And are they always binary? So you can't have like good, medium, or bad. It's always good or bad.
Okay, so it all depends on how you can define it. I'm not really sure how you would define like a medium review, because yeah, that's like kind of hard to define, like even like a neutral review. Like how do you know it's neutral, you know? Okay, so now that it's trained, we're going to test it on our testing set. And do you guys recall from the quiz what the difference between the testing and training sets are?
So the testing is labeled and the training is where it's not labeled and the machine does its magic. I'm sure that's not the we shouldn't say magic in an ML workshop.
Doesn't it try to guess basically from so you have, as you said, the data is labeled when it's the training set, and then when it's not labeled, it's just trying to guess which the right answer is. Your training working basically?
Yeah. Yeah, that's perfect. So I just got a question that says, what does it mean for data to be neutral? I don't know what you mean by that, but what we were talking about earlier is Neela asked if you could also detect if like a tweet or a text was like neutral, as in like it didn't really have like a positive or negative opinion, and I just said like that would be kind of hard to tell, because like how do you know if it's like really neutral, if they're being like sarcastically mean or something, you know? So that's all I said. And then I just got a request to increase the font size, so is there any way you can zoom in possibly? Okay.
Is that
perfect.
okay?
Yeah, is that good, everyone? Okay, yeah, I think they said yes. So now we're going to test our classifier on the testing set, and we're going to look at the accuracy. So as you can see, the accuracy was 82%, which is pretty good considering we haven't done any pre-processing of the data. And now we are going to look at what were the most important features that naive Bayes decided on. So I guess if you press run for this cell down here, the cell underneath that.
Oh, sorry.
Oh, that's okay.
Yeah.
Okay, so naive Bayes said words that had atrocious, unimaginative, Schumacher, and shoddy and Suvari were the words that were like the most important features in deciding whether a review was negative or positive. And as you can see, if there was shoddy in the review, then there was a 7-to-1 chance that that review would be negative or positive. And so you can see that this is kind of how the naive Bayes is looking at classifying reviews. It like looks at like what words are most common in the negative reviews, and then it tries to look for those words in reviews it's never seen before to try to classify it as positive or negative. Okay, so yeah, that went by really quick because Nila had like, I'm sorry, am I pronouncing your name right, by the way?
It's Nella, or it doesn't.
Nella?
Yeah.
Oh, sorry, Nella.
Sorry.
Because Nella had like no errors in her Google Colab. So yeah, that's pretty much the entire introduction to NLP workshop. So I guess we could just do like an open Q&A section now.
It's your first time with no errors, Nilla?
Sorry?
Was that your first time with no errors in the collab?
Yes. So lucky. Last times, every time, couldn't do it.
So it's good to see everybody back on the screen. Zooey, thank you so much for taking us through that last section and, of course, everything that preceded it. I'm curious, I mean, some of us were watching Nella's screen. I know that I was. And I wonder if others were doing their own at the same time. And if anybody would like to share that experience, how they were getting on doing their own. Violet's waving at me.
Yeah. So my accuracy only came up to 75%.
Okay.
Was that just like, did you change anything or no?
No.
Oh, yeah. I mean, when I did it, I got 92, so.
Okay, so there's quite a large spread. So I think Neela got like 81 when she ran it, but 82 that was initially there. So it can be as good as 90, and it could be as low as 75.
Yeah, and I think if we were to continue working on this project like long term, we would probably go through the corpus or the vocabulary and like weed out words that we deem to be not helpful to kind of help them out, and that might help increase their accuracy or something like that.
But my question was more about where does the variation arise from in the first place? Why are my results different from yours?
I mean, just because we've done like no data pre-processing, so it's...
But we use the same data, you and I.
Yeah, but it's kind of being thrown in randomly, so like because it is random, it's if you do it like 1,000 times, it'll probably even out to 50%.
What about 50? But you know, somewhere between your 90 and my 75, hopefully.
Yeah, like it'll average out.
Yeah, so it's the random shuffle at the beginning that makes me get a different training portion from, you know, if I loaded it up again tomorrow, I'd get a different result because it would be shuffled differently. So when you split the entire data set into the bit you're going to use for training and the bit you're going to test it on, you'll get a different split each time. And that's where the variation arises.
There's a couple of comments in the chat. Zooey, if you want to look at those.
Yeah, we're also getting some pretty good like possible reasons for why the accuracy is not consistent in the chat. So those could also be good reasons.
Great. Anybody want to share their experience?
I saw in the chat somebody said they got shower as one of the important word outputs, and that is hilarious because I would think that is a neutral word, but I mean, okay.
Yeah, it's like Nilla had Schumacher, didn't she? I was like,
yeah.
I had Schumacher as well.
Did you?
So obviously they're very against Schumachers. And then shower can be derogatory, that you know that it was an absolute shower.
Oh, is that really a term? I didn't know that.
A something storm, but I can't say the word.
Yes. Anybody else want to share their experience or just try a little project? We've got some great words in the chat, so that's fun to see. Question there from Siham. Zooey, if you want to grab it quickly.
By NN, do you mean neural network?
I assume so, but...
Okay, so
yeah.
Naive Bayes is not a neural network. It's just a regular machine learning model, but some neural network models that you could use would be like neural networks or like recurrent convolutional neural networks or convolutional neural networks. But convolutional neural networks are usually used for like image processing, but you could try using it here. And fast RCNNs, so fast recurrent convolutional neural networks. And yeah, there's a ton because people are coming up with like different variations of like layers and everything, different architectures every few years. So yeah.
Nella, how did that compare to what we were doing last time with computer vision?
What?
How did you get on this time in comparison to the work we were doing last time?
No, the last time was really great as well. I mean, like I was able to actually make a model, but what I preferred from last time is you could see the data. Here with the movie review, you can't really see the data, so you don't know how it's inputted in the beginning, and so you have to trust Dewey that it's actually movie reviews. Don't know actually. Might it be culinary reviews with Schumacher?
Yeah. I guess like because the data set is like 2,000 words, you could print it out if you wanted to, but like, do you really want to?
So a question there from Matt again. Could support vector machines be used?
I'm trying to think. So support vector machines are usually used in, I think, yeah, I think they could be used. Well, I'm trying to think like what.
Oh, Violet's contributed as well, yeah.
Oh, sure.
Yeah, SVM's all good. No reason not to.
Yeah, but I like forgot what we were doing here, so I wanted to add more to that, but I forgot what we were doing. But yes, they could be used.
Terrific. Okay, so we're coming up towards the hour. So open questions for Zooey, questions for the group. This is your chance before we close down the meeting this time for the end of the year. How might this get you? Is anybody thinking about incorporating some NLP into their work or their projects?
I had a question. I'd just like to know how I can follow up on some of this information. He's following some kind of a pattern, I guess, in doing all this. Is there a list or a set of instructions or documentation someplace, maybe that Violet has, or whatever? Some of it I pulled away from. I have a real job going on at the same time.
For what exactly? The coding section?
Yeah, for any of the reference stuff that you're using.
Okay, so for references, a lot of it is like notes I've taken over the years, but I can point you to the courses that I took and then also the tutorials that I like pulled stuff from.
Right.
And we've also got the WhatsApp. There's a specific WhatsApp group for people who are on the workshop, so we can continue dialogue and discussions on there and ask questions, I think.
Okay. Maybe I'm just not familiar enough about exactly how the group is organized. I just joined in a couple of weeks ago. And my other question was, how did I miss the thing this morning, the visual?
The visual?
Do you mean the image recognition workshop?
Yes.
That was last month.
You didn't miss it.
Okay.
Oh, and also I'm pretty like,
I thought it was this morning the way y'all were talking.
oh, no, sorry. I said like earlier, like last month, earlier this year. Sorry about that. And then also in case somebody did, want to see the data, I just tried printing the data set and I got an error that said the notebook server will temporarily stop sending output to the client to avoid crashing it. So there we go. I guess we can the first word or something.
So you had mentioned that there is some exercises or reference or documentation you're using with the group or something like that.
Like the library?
Whatever's I'm not really sure what this group is. I know I'm enjoying it.
Like
well,
the WhatsApp group?
I don't like to talk over people, but I'll jump in if that's useful.
Yes.
Yeah, sorry, Richard, you could go.
So, Dean, as you know, this group is MKAI. I won't bore everybody with the background particularly, but for what it's useful, MK, as I said, stands for Milton Keynes, which is where we formed this group to help people to connect and grow their understanding and knowledge of AI at all levels. Our physical events became digital events. I don't need to explain why that happened earlier this year. And it's attracted in an international audience, of which we're hugely grateful. We've been backed by our local council in Milton Keynes, so of course gratitude for them. And as part of the global challenge that we have now to think about levels of unemployment and reskilling, particularly into digital, we wanted to go even further than just doing our events to get people together and to learn about what was going on in industry. And we wanted to actually get hands-on. So we jumped in and we decided that we would do lots of prep and lots of planning and also learn as we go and have a really collaborative learning environment. And you've all been a part of that. And we said, let's do these 3 sessions leading up to Christmas. And then over that break, let's talk about what's worked, what learnings we've had, what feedback we've had, so that we can go from strength to strength and really start to build out. So lots of things we'd love to do. We'd love to have more connectivity between the sessions, start thinking about some projects. We obviously want to connect people more into their own learning journeys. And we as a larger group are exploring loads of different avenues, including how we might even be able to do some training and things like RPA, so that people have immediate skills and things for their CVs.
That'd be wonderful.
Yeah, so we're excited. We're doing everything sort of one stage at a time. And Dean, to answer your question completely openly, we're learning together, and please be kind with your feedback. But we love the feedback so that we can get better and better. And if people want to get involved with this, then it's obviously free to attend. Everybody helping here is giving their time, and we want to make this a space where all of us are helping each other and supporting each other and learning at the same time. That's pretty much it, Dean.
I hope that my feedback has been nothing but positive. I can't think of how I would give anything else. I'm very impressed with what y'all do and excited about having the opportunity. And RPA, you got to vote for me on that one.
Oh, very cool. No, Dean, you've been fantastic and so kind in your words and your actions. So thank you. And everybody has. I mean, it's
really enjoyed this.
And all credit to Zooey, of course. And it's not that she's 16. It is cool that she's 16, but she's just so much passion for her work, and we're so blessed to have her here.
Yeah, I don't really. If I cared about how old people was, I'd be in trouble.
We don't care either, Dean. We're all going the same way, so
y'all just need to catch up.
Entropy will get you.
Some of us have more of a head start.
Like I said, I was just wanting to know where I can get more material. Not that I'm gobbling up everything you've given me yet, but it's been good.
So let's take that action, Dean, and let's try and put some stuff. So if I'm just putting the WhatsApp group up here again. This is just the private group for the people that have been on these sessions. It's a safe space, ask any questions that you want. And let's see if over the next few days and weeks, we can put some journeys and materials in there. But Dean, on a serious point, and it's something I got approached about recently of would I help co-start an institute in the UK, because there is a real question about learning paths. Some of us are on our, degree, masters, whatever learning paths. MK stands for Milton Keynes. That's where we began. That's where we were first started. But the rest of us have got millions of options, right? Literally. Whether you're talking about Udemy, LinkedIn Learning, Coursera, or any other things. And I think there's a real opportunity to look at learning paths based on levels and different types of role that you want. Not everybody wants to be a data scientist, right? That's why we had Sharon earlier talking about different roles in her organization that are, in AI, but not doing AI. I think it's a huge opportunity. I don't know if anybody shares my thoughts on that.
Absolutely.
Yeah, I would say Andrew NG's Coursera course is the most comprehensive resource out there. So, yeah. And then he has a whole company. It's called deeplearning.ai.
What's the cost of that? Is that like 30, 40 pounds or something?
Well, if you want like the certification, then I think you have to like pay $49 or something. So however many that would be in pounds. But if you just want to learn, then it's free.
It is deeplearning.ai.
Yes. You might want to double here, let me see if that is the right URL. Yeah, it's deeplearning.ai. And then Stanford has, for some reason, I don't know why, but they record all of their lectures online and they post them on YouTube. So they have like this entire YouTube series for, I forgot what it's called. It's either CS 224 or like something in the 220s or 230s. And that's like their Intro to AI series. So if you want to watch YouTube videos, you can watch that. And that's taught by Andrew Ng. So yeah.
Would you be happy to put those in the WhatsApp coding group when we finish the call, Zoe? Thank you so much.
Yeah, sure. So yeah, those are basically all the resources I used. And then if you want like something bio-focused, my nonprofit runs workshops, and there's like a couple of textbooks that I read, but the coding was kind of like really advanced. It was for like CS majors, so, and CS is like not my thing, I just like the theory. So you can take that as you will. I can also link those.
Great.
Yeah, those Stanford courses and the Coursera, yes, they're very comprehensive. They're quite involved. So yes, computer science majors are kind of their target audience. So for me, the difference with this group and this format is that it is just so much more interactive. The always available stuff, yes, it's there, but actually in some ways that both reduces the incentives. You can always put it off. It'll still be there tomorrow. There's no rush to do it today. Whereas, you know, a timed thing, a timetabled thing has, you know, keeps you going. But it is the interaction.
Try to have a seat if you can find it.
With the teacher that you can ask questions that is less available, shall we say, with a lot of these pre-recorded online courses. And I think that's really valuable.
Terrific. We've got 30 seconds left.
Can I say thank you very much? I really, I've gone from no knowledge at all to being able to have, well, I can speak to other people who have no knowledge and sound like I know what I'm talking about, which is wonderful. And thank you very much, Richard, for setting all of this up. Georgina and Violet for your inputs. Nilla for letting me pick on you and being my learning buddy. And I wish everyone a great Christmas.
Same to you.
Yeah,
thank you all.
In the land of the blind and all that. Let's have a great Christmas. What's that old expression where the lion's chasing those two guys? And one guy stops and starts putting his sneakers on, and he says, "You can't outrun a lion." He goes, "Nope, but I can outrun you." And so let's just do what we can do. Thanks, as always, everybody, for getting involved with putting a smile on my face, certainly, making this the most inclusive, interactive session that we can make it, striving to be right, as you could see all the way through, challenging ourselves as well. Massive thanks to everybody. Violet for getting involved, Georgina for getting involved, Bridget, of course. Jazel is here as well. Those that have been more vocal tonight, the Deans, the Stevens, the Matts, the Nellas, and of course everybody else has been on the chat as well. How come I didn't know about you guys before? Well, maybe we were a well-kept secret, and maybe we can change that. But we're you. This is MKAI. It's not one of us. It's all of us. We're just trying to learn together, grow together. And massive thanks, of course, to Zoe as well. You are my hero. You always will be. And we will be back in January. And we've got at least 3 more of these, and we've got a lot more to do yet. So come and join us again. And until then, have fun.
Thank you all
very much.
Bye.
Thank you.
Thank
Happy
you.
holidays.